In this video, we're going to explore sequences and series, what they are, how to work with them, and how to find their sums. Let's start with the basics. A sequence is just an ordered list of numbers, arranged according to some rule or pattern. These sequences can be finite or infinite, and each number in a sequence is called a term. Here are a couple of examples. 2, 4, 6, 8. That's a sequence where each term increases by 2. Or 3, 6, 12, 24. Where each term is multiplied by 2. Now, when we talk about a series, we mean the sum of the terms in a sequence. So if the sequence is 2, 4, 6, then the series would be 2 plus 4 plus 6. To work with sequences and series, you'll need to be comfortable with basic algebra, arithmetic, and spotting number patterns. Now let's talk about arithmetic sequences. An arithmetic sequence is one where the difference between consecutive terms is always the same. For example, 2, 5, 8, 11. Here, the common difference is 3. Look at the diagram below. You'll see how each term increases by the same amount, 3, as we move along the sequence. The general form of an arithmetic sequence looks like this. A plus D plus 2D, A plus 3D, and so on, up to a plus n minus 1 times D. To find a specific term in the sequence, we use the formula as written below. A sub n equals A plus n minus 1 times D. Here, A is the first term, D is the common difference, and n is the term number you want. Let's try an example. What is the 15th term in an arithmetic sequence that starts at 5 and increases by 7? Using the formula, A sub 15 equals 5 plus 14 times 7. That's 5 plus 98, which equals 103. Now, if you want to find the sum of the first n terms of an arithmetic sequence, that's called a partial sum, we use the formula S sub n equals n over 2 times the sum of A and A sub n. Next, let's talk about geometric sequences. In a geometric sequence, each term is found by multiplying the previous term by a fixed number, called the common ratio. Here's an example. 2, 4, 8, 16. Each term is multiplied by 2. Look at the diagram below. You'll notice how each step multiplies by the same value, in this case 2. The general form of a geometric sequence is A times R squared, A times R cubed, and so on. To find the nth term of a geometric sequence, we use the formula A sub n equals A times R to the power of n minus 1. Here's a quick example. What's the sixth term in the sequence 2, 6, 18, and so on? The first term is 2, and the common ratio is 3. So we do 2 times 3 to the fifth power. That gives us 2 times 243, or 486. If you want the sum of the first n terms of a geometric sequence, the formula is S sub n equals A times 1 minus R to the power of n over 1 minus R, as long as R isn't equal to 1. Now let's move on to infinite series. Some series don't stop, they go on forever. We call these infinite series, but not all of them have a finite sum. If an infinite series has a finite sum, we say it converges. If not, we say it diverges. For a geometric series to converge, the common ratio R has to be between -1 and 1, like the formula I have shown below. If it is, then the sum of the infinite geometric series is A over 1 minus R. Let's try an example. What's the sum of the series? 1, 1/2, 1/4, 1/8, and so on. The first term is 1, and the common ratio is 1/2. Plug it into the formula, 1 over 1 minus 1/2. That equals 1 over 1/2, which gives us 2. And that wraps up our introduction to sequences and series. You learned what sequences and series are, how to work with arithmetic and geometric sequences, and how to calculate sums. Take a moment to go over the key formulas and try a few practice problems to reinforce what you've learned.